Hi everyone, welcome to my channel. My name is Ahmed. Today I will break down everything you need about fascinating machine, which is bomb. I believe most of you hear about it and seen it, maybe work with it. So let's get started. So what is bomb? Bomb is a equipment that used to move fluid, liquid or gas from a place to another place by using a mechanical action, of course. And it might be seen in water supply system, a fuel station, in oil and gas sector, pharmaceutical, even residential and your home. Even if you have water pressure is low or something, you need to get like a booster pump to help for pumping, and you get a good water. And there is two types of pump. Bombs are two types. Centrifugal bomb, which is gonna be the main thing of today, and positive displacement bomb we're gonna speak about it later. But the positive displacement has two types, like a reciprocating and a rotary bomb. Reciprocating is based on the piston action, like a piston pump, plunger pump, diaphragm pump, and a rotary pump like a gear, loop, screw, and van pump. But in positive displacement pumps, they care much about delivering high pressure, and the flow rate is a little bit moderate. Unlike centrifugal pump is caring about delivering high flow rate and get like a moderate pressure. So for high pressure, you can use a positive displacement pump. For low pressure or average pressure, you can use centrifugal pump, but of course you will get a high flow rate. So let's get started with our topic today is going to be centrifugal pump. So what is a centrifugal pump? Centrifugal pump is equipment convert a mechanical energy to kinetic energy by centrifugal force. So centrifugal force, imagine have like a water in a wheel rotating. So yeah, that's a centrifugal force, how it looks like. Um, so the pump has two main components, two main parts, like a stationary, like casing and peering and rotating impeller and shaft. The impeller and shaft considered like the most important part of the centrifugal because the impeller is used to pushing the liquid through and give it like the energy needed, which is translated to pressure afterwards. We're gonna get to this in the next slide, of course. Um, there is a classification of centrifugal pump. Um, three classification like radial flow, axial flow, or mixed flow. So, what is the radial flow? Radial flow is whenever you get a liquid in a suction line. So in case there's a radial flow, here we have like, I hope this image is, explaining much, and let me maximize it for you. Sorry, I didn't rush. So yeah, so here is the impeller. Here there's a casing, and here should be like a suction line on the inlet line. So whenever the liquid, for example, water is pumping in the suction line going to, suction eye or impeller eye, which has low, low pressure, and then it starts like rotating, the liquid will be perpendicularly flowing upward to the discharge line. So it's going, so the blades of the impeller is directing the flow perpendicular to the shaft directly to the exit to the discharge nozzle over here. Unlike the axial, as you see here, the fluid is going, you know, through the impeller vents over here and can go through and parallel to the shaft at the back and then is going upward to uh, discharge line or discharge nozzle. So the main difference is the direction. And of course, in order to do this, you have to change in the configuration of the pump itself. And based on the application used, if this application need, or maybe the cost, maybe the application you use for. So many factors used is based on um, the manufacturer, based on the liquid you're handling. If you do water, if you do something with high viscosity, is different. As you do something with low viscosity, is something else. So many reasons you can use what type of axial or radial. And and the third picture has mixed flow, is something in between both. Um, but yeah, but this not common in the industry too much. Um, Here I have like a side view of centrifugal pump, like a regular one. Here we have like this is a side view of a centrifugal pump. Here is a suction nozzle where the fluid is goes through. Of course, here there is like a pipeline connected, and here there is a suction eye or the impeller eye, where is pressure is zero, and here there is a blades of the impeller, and there is a shaft is connected, is attached to the impeller. Um, Here you have the casing where where contain all rotating parts, and here is a bearing. Bearing is responsible for the stability of the shaft and make sure the shaft is rotating smoothly and nice without any noise. And of course, maintains alignment, because it's very important to keep the impeller and the shaft on the same line, on the same level, because if there is a level difference, it's going to be a problem. Um, Here we have a seal. Seal is responsible for mechanical seal, or most likely is backing. So the backing is a polymer material. It used to prevent liquid or pumping fluid is going outside the pumping area to outside to the machine to the other rotating parts. Um, yeah, that's like a small image, about centrifugal pump. We have a real one over here. Yeah, this is much better. Uh, yeah, we have same thing. This is like a discharge nozzle, a shaft, and of course over here it should be the bearing, or the bearing house over here. Um, Here the suction line, some flanges, of course, not. Yeah, it's based, on what type of centrifugal pump is used. It has so many different designs based on the application and the manufacturer, what kind of pump it used. Um, so the main parts of centrifugal pumps is number one is the impeller. What is the impeller? The impeller is a rotating part of centrifugal pump, and has like series leads, curved or maybe straight. It depends on the application, the course, and is connected to a shaft, and the shaft is connected to a motor, and the motor it can be working with electrical power. So how it works? So the motor is transmit rotational energy through the shaft to the impeller, so the impeller is keep rotating and rotating the liquid, and of course it applies a centrifugal force and divert it outside to the discharge nozzle. So the impeller has two types, is enclosed and open impeller. So when I'm gonna use the enclosed. So the open impeller it used with a low viscous liquid like water. It's okay. You can use with it, no problem. Um, with high viscous, you can use enclosed impeller. It's okay. You can use as enclosed impeller. Oh, sorry. No, I mixed it up. So the open impeller it can use with a high viscous, no problem. But with enclosed one, you can use it with low viscous. Because if I use like a high viscous in the enclosed impeller, it's gonna be a problem and it's hard to clean up because after a period of time, the pump need to be, it might go for a maintenance and maybe deassemble every parts and do like a maintenance needed. So in order to cleaning the impeller from residual fluid, so we need something to easy to handle. So if something like with high viscosity, so I believe the open impeller is going to be a good option. But enclosed, if I handle high viscosity, it's going to be hard to clean it out. So of course it's going to go for low viscosity fluids. And I believe also open impeller can handle both. But it depends on the application and any kind of application and manufacturing they use. The shaft, of course, uh, is very important part in centrifugal pump, and you know, is seated on a bearing over here, and the bearing is responsible for keep the shaft rotate smoothly without noise and make sure the impeller here and the shaft both on the same line without any problem. And of course, should be like a coupling over here and a motor at the back, where the motor you can, when you start up, give like, uh, you know, the shaft purpose to transform like rotational motion needed to the impeller to keep the impeller moving and moving. Yeah, it's a bearing. We already talked about it. Packing is over here. Yeah, it should be somewhere over here behind, behind the impeller. Make sure that the liquid, here I can explain more better. Yeah, so the backing or the seal is over here. Is a polymer material is already used for preventing uh, preventing leakage to go from inside to outside. So yeah, so this is like a simple, component it used for it, and I believe it's very handy pump. Yeah, it's used in everywhere, and the component is easy and handy, unlike other pumps, of course. Um, yeah, for the suction line, should be there is a strainer. In case the fluid has like a particles, and this particle if go inside the suction line and it's gonna start collapsing the blades of the impeller. So in order to avoid this, you should have like a strainer to collecting every part or particle uh, in the inlet line. Um, you have a seal chamber where we have like a mechanical seal and is provide like a space and a lubrication and coolant and to avoid the pump to wear during pumping. The motor is considered like the driving force. So without motor, with no pump. So the motor is connecting to to the shaft, and it can be worked with electric or diesel. Um, volute, yeah, here the volute or the diffuser. So what's the volute? The volute, is the area here. That's the volute. So when the liquid get in, so it go in as like the impeller eye, and then the impeller start rotating and apply centrifugal force. So the liquid afterwards is leaving the impeller is going to the volute, the area around the impeller, or it can be called like a casing, another casing, because it has like a rotating part as well. So when leaving, the volute is playing important role to lower the velocity of of liquid, and when the lower the velocity, according to Bernoulli equation, the pressure is going to be high. So that's how you get high pressure inside the pump. So that's the importance of volute, and then it's go directly to discharge nozzle. Um, yeah. So how the pump it works? But before it works, there is something called priming. It's very important to know about it, especially in centrifugal pump. So the priming is, before you start a pump, you have to fill the pump casing with liquid to make sure there is no air inside of it. Because if the pump is sucking air, uh, the pump will never work, or maybe work in a different way, and you will not get the high flow rate you seeking, or the pressure you seeking. So centrifugal pump is handling liquid only, not handling gas or air. So make sure not sucking air in the line, in suction line. So before you start, you have to priming, fill the line, and fill the pump with liquid, whatever kind of liquid, water, if you pump on water, um, slurry, um, anything, anything related pharmaceutical, oil and gas, what oil, anything. Just fill it with the liquid of service. Make sure the air is out, then you can start the pump. Um, how the pump work? I believe we mentioned this, but like the fluid enters the pump in the inlet line or the suction line, and the suction pipe is attached to the inlet of the pump. Of course, there is a flange and the gasket in between both connected, and the impeller rotating. And impeller rotating how is connected is attached to a shaft, and the shaft is attached to um, the motor, attached through a coupling, of course. So the impeller is keep rotating, apply centrifugal force, and push the liquid outside the center of impeller, or the center of the suction, and let's go to the volute. And I told you how volute work. So lower the speed, because the volute is designed in a way to lower, has like graves or whatever, to lower the speed uh, of fluid, and which is converted afterward to high pressure according to Bernoulli equation. So yeah, you say kinetic energy is important. So the fluid is forced outside, gain velocity, and the kinetic energy, the casing around the impeller. Um, energy conversion to pressure, volute or diffuser help to slow down the velocity of fluid, converted to kinetic energy to pressure energy. And then fluid exits the pump. The pressurized fluid can exit the pump through discharge pipe, and ready to send to the system. You see, whatever the system is, maybe your water tank, maybe going to a heat exchanger, maybe it's going to a separator, maybe it's going to a furnace, maybe it's going to anything. So yeah, that's it. Yeah, gave you like a quick overview about bombs. I hope this video you like it, and I'm gonna later in next video I'm gonna speak more in detail about bomb or anything related to bomb. If you like it, please hit subscribe, like, and tell me in comments if anything interesting in mechanical engineering or bomb specifically I can help and do a video about it. Thank you.